So make sure you have your name on it. We are block 2 of day 1. And you got Baby Yoda, because you'll be masters of solving equations by the end of it. Frustrating, but there is a good feeling of accomplishment when you get to the end of it, because you're actually doing quite hard math, and it seems easier. Okay, now before we get going, all right, I'm going to set up something that we call an expression. Okay, that is an expression. Soon as I put an equal sign and it equals something, it becomes something we call an equation. Right? So I can go this, and you know 4 plus 6 is 10, but I can go 3 plus 7. Right? They're still equal. This side 4 plus 6 is 10, and 3 plus 7 is 10. They're both equal. Right? Now, when we think of equations and equal signs, we have two sides. We have a left side and the right side, and these sides must always be the same, have the same value. That side's 10, that side's 10. Think of it as a balance. The left side has to always equal the right side. So if, I'm going to just put a little line down the side in the middle here. If I decide to add 5 to this side, this throws this in balance. Now this side is worth more, right? If I add 5 to that side, I have to add 5 to this side. Okay? That makes sense, right? To keep things in balance, right? Or if I decided to, say, not add 5, but if I decided to, say, multiply by 2, 4 plus 6 is 10 times 2, you get 20. I'd have to do the same thing on this side. Okay? You have to multiply by 2. Right? And that process right there, that idea of whatever I do to one side, I must do to the other side, is basically what this whole chapter is based on. Okay? We're going to use that idea in different ways to help solve equations. So instead of having 4 plus 6 is equal to 3 plus 7, we're going to have something like 4 plus x is equal to 3 plus 7. This is more of a grade 8 kind of question. Right? And it's very similar to what we have over there. Right? And most of you guys don't really need to do any math. You can do it in your head. You can tell me what the value of x is, right? Right? Remember, letters are just numbers that we don't know the value of yet. Okay? And the way we solve equations is by finding the side that has the x on it and getting rid of all the numbers that exist on that side. And all you have left was the x, and we know what the value is. And I'll explain it a little bit further with an example. Okay? So on this side, if I want to get rid of this 4, well, it's adding to the x. Opposite of 4 is, positive 4 is negative 4. So if I subtract 4 from this side, because positive 4 and negative 4 make 0, they cancel each other out, right? That makes 0. I have to do the same to the other side, right? To keep this in balance. I subtracted 4 on this side, I'm going to subtract 4 on the other side. So I go subtract 4 on this side. So I'm left with just the x over here on this side. 3 plus 7 is 10 minus 4 is 6. And that is how you are going to figure out the value of x in general. A little more in detail. And this seems like a lot of work now. You see, you can just stare at this and you know what the value of 6 is. But when we get into equations with fractions and decimals, you can no longer just look at it and figure out what the number of x is. You need to know what the mental process that you do in your head. You actually need to know the steps. All right? Because you can't just look at it anymore. Okay? So let's just put some words in here and fill out our notes. So a statement that has two mathematical expressions, that's an expression. And that is an expression that have equal value is called an equation. Right? Two statements that are equal is called an equation. Okay? And just like the previous chapter, to keep things straight, communication is a little bit open. We need to know some terminology. Right? If this is our equation here, what do we call the x? That has a name. You used it a lot. What is that x called? Huh? Starts with a V. Taylor?
Variable.
Yeah. So x is variable. We're going to say isolate the variable a lot. All right? Now, there are also two types of numbers. There are numbers that are attached to the variable, like the 2. And there's numbers that are not attached to the variable, like the 1 and 5. They also have names. And each of their names starts with a C, two different words. Does anybody remember what they might be? Either one of them. Right? Abby, do you remember? Coefficient? Sorry, which one's the coefficient? Yeah. 2 is the coefficient. The number attached to the variable. Okay? And how about 1 and 5? The ones that are not. Lachlan?
The constant?
Yeah, constants. Right? So just some terminology, or constants in this case, is plural. Terminology to help us talk. So we're not saying that number, this number. We have some words that we can use. Okay? So, in our attempt to solve equations, what we do is we apply the opposite math operation, or inverse is the word. Okay? So there are 4 kind of arithmetic operations. We have adding, subtracting, multiplying, and dividing. To solve, we always do the opposite of what's happening. Okay? So we just need to be clear what the opposite of each thing is. If we have addition, what is the opposite of addition? Subtraction. Thank you. Oops, I want blue. Subtraction. All right. Now, if we have subtraction, what's the opposite? Riley?
Addition.
Thank you. All right. 2 more to go. If we have multiplication, what is the opposite? Division. All right. And finally, division, the opposite would be multiplication. Right? Right? So, in our attempt to solve equations, you need to be asking yourself the question. You're trying to get a number, you ask yourself, what is this number doing to the variable? Is it adding to the variable? Is it subtracting? Is it multiplying? Is it dividing? And we do the opposite of that. Right? So, right here, you can probably just look at that and tell me what the answer is. Right? What's the answer? Lachlan? Yeah. But let's go through the math operations. Because when this becomes a decimal or a fraction, that becomes a little bit harder to do. So I'm going to draw a line. It's not it's optional for you if you want to draw a line. Some students, it helps separate the left side and the right side together. Okay? So this is how it works. Okay, you find your letter, your variable, and we look for all the numbers on that side. That we're going to get rid of. So on this side, we just have this 3. This needs to be removed. And you go to yourself, what math operation is that 3 doing to the x? Is it adding, subtracting, multiplying, or dividing? It's multiplying. And what's the opposite of multiplying? Dividing. So to get rid of this 3, we're going to divide by the same number. So we divide by 3, right? Or you can say multiply by 1 over 3. It means the same thing, right? Divide by 3, multiply 1 over 3. We do this because if you remember from your fractions unit, a number on the top cancels out a number on the bottom. That's how we get rid of that 3. And remember, we are doing this if we do something to the left-hand side, we have to do it to the right-hand side in order to keep it balanced. So we go, hey, I multiplied by 1 over 3. I have to do that to this side as well. So on the left side, we're left with an x. On the right side, we're left with a 6 times 1 over 3. Right? And that's like, when we're multiplying fractions, it's maybe sometimes nice to have both numbers as fractions. We multiply the tops together to get the numerator, multiply bottoms together to get the denominator. So 6 times 1 is 6, 1 times 3 is 3, so we get x is equal to 6 over 3. Then we can look at that and go, simplify that fraction down to x is equal to 2. Okay. A lot of work. Lachlan said the answer is 2 right off the bat. But when the numbers get more difficult, we need to go through that process. Right? Is that doable? All right. I'm going slow on purpose because there's a lot of frustration that happens. Okay, there's a couple questions we're going to do here. All right. So next question here. So got my two sides, left side and right side. The x is over here. So on this side, we have this 3 now. What is this 3 doing to the x? Is it adding, subtracting, multiplying, or dividing? What is it doing? Yeah, it's dividing. A fraction line, this fraction line here means to divide. Okay? So to get rid of this 3, we do the opposite of division, which is multiplication. So instead of dividing by 3, we're going to multiply by 3. Right? And whatever you do one side, you have to do to the other. Okay? We multiply by 3 because a 3 on the top with fractions will cancel a 3 on the bottom. So that 3 disappears. So you're just left with an x on that side. And what do we have on the right-hand side? What would that be? What do you think, Ethan?
18.
Yeah. So you go 6 times 3, 18. And that is our answer. X is equal to 18. Does this look any familiar from last year? In grade 8?
I didn't do math last year.
Yeah, for the people who did.
Same here.
Right? I'm hoping it's starting to ring some bells. Right? Because in grade 8 you did a lot of one-step and a little bit of two-step calculations. Right? And it just depends on the teacher you had and the wording that they used to help explain these. Right?
I remember Mr. Blaine.
Yeah, that was 2 years ago.
He was rambling.
Yeah. So we divide this, right, at the equal sign. Not the halfway point, and where the equal sign is. That separates the left side to the right side. Right? Then you look on the side where the letter is, the variable, and we have this 5 sitting here that we need to get rid of. So you ask yourself the question, what is this 5 doing to the x? Is it adding, subtracting, multiplying, or dividing? What is it doing to the x? Yeah, subtraction. Subtracting, the minus sign. And what is the opposite of subtraction? Addition, right? So to get rid of this 5, we have to add 5. And whatever we do to one side, we have to do to the other. Okay? And the reason why we add 5 is because you go negative 5 plus positive 5 gives us 0. Right? So that equals 0. So those are gone now. And you're just left with an x. How about on the right-hand side? What are we left with?
16.
Yeah, 11 plus 5. Answer is 16. And once again, you've probably done that on the head.
You should that all?
Yeah.
Cross out both 5s on the left side or just the...
Both 5s. Because negative 5 plus positive 5 equals 0. So both of those 5s, you combine both of those 5s together to make a 0. So they're gone. Okay, so now, the beauty of this chapter is, for 99% of the questions, you can check to see if you got the answer right. Right? You can come up with a number for x. You can tell if it's right or wrong. I'll show you the process. Right? So all 3 of these questions, most of you guys could have probably just looked at it and told me the answer. this question here. Can somebody just look at this and tell me what the answer is? What is the value of x? To make this left side equal the right side? Right?
Division.
6.66?
0.66. No, 0.66.
No, close, I think. No. 2 divided by 3 is 0.66, so it wouldn't be that. Okay, so let's go through the calculations, and we will check. All right, so we separate at the equal sign, the left side versus the right side. Okay, and on the side of the x, we look at the number. We have a 3 sitting here. What is that 3 doing to the x? Mathematically, adding, subtracting, multiplying, and dividing. What do you think, Jacob? Multiplying. So the opposite of multiplying? Division. So we divide by 3 or multiply by a third. Means the same thing. Right? And whatever we do to one side, we do to the other. Multiply by 1/3. Right? So a 3 on the top will cancel a 3 on the bottom. That's why we did it. That was the whole reason, to cancel those 3's out. So you're left with just an x over here. And what do we have on the other side? We have 2 fractions multiplying together. What should our numerator be? What should our denominator be? Sorry, what's 3? No, the denominator is not 3. Thank you, it's 9. We multiply the bottoms together. 3 times 3 is 9. So what's the numerator?
3.
Nope.
2.
2. Multiply the numbers on top. 2 times 1. 2.
Oh yeah, because you can't multiply the same number.
Yeah. So this is our answer. And if you go 2 divided by 9, and the sortage guess was a 0.66. 2 divided by 9, 0.222. So your initial guess was not correct, right? Okay, let's check to see if we did this right. Okay, so this is how you do checks, right? And the way we do checks is we start off with the side of the equation that has the variable on it and see if it equals the other side after you plug in your numbers. So we're going to start off with the left-hand side. That's what LHS stands for, left-hand side. All right? And when you get into grade 10 and grade 11, you can do proofs, and you use that phrase left-hand side and right-hand side a lot. More so in grade 11. All right? So on the left-hand side, we have 3x. Right? And our answer that we came up was the value of x is 2 over 9. So where we see x, we're going to put in our answer, 2 over 9. So here's a 3. And when we put in answers, a variable, we'd always do it in brackets. 2 over 9. Okay, so we just need to calculate this. And with fractions, it's sometimes easier to make this over 1. What do we get if we multiply this together?
9 over 6.
Sorry?
9 and 6.
9 and 6, right? 6 over 9 like this. Now, does this equal the other side? It should have equaled 2 over 3 if it was right. Did we do it wrong?
No.
No. What more steps we need to do?
We can reduce it.
We can reduce this. We can divide the top by 3. We can divide the bottom by 3. So that ends up being 2 over 3. Right? Which equals the other side of the equation, the right-hand side. So you know you did it right. So if there's any doubt, you can always plug your number back into the equation. And if it equals the other side, you've done it correctly. It is a lot of work. And I say it's not a lot of work. It is a lot of work to do that. But that's the steps you need to go through to check. All right? And as you get higher in the grades, the questions just get more complicated. So we're not going to go through everything on this page. I'm going to hand select a few and just sort of see how they go. All right, then we'll do some warm up next day before we do the assignment. So let's start off with this one here. Right? Where we see the equal sign, we draw our division here, our separation. Okay. What number are we trying to get rid of here? Can you tell me that? What do you think, Ethan? The 2.3. Okay? So what is the 2.3 doing to the x? Dividing. So the opposite is? Multiply. So you multiply by 2.3 to this side and the other side to keep it in balance. Okay? A 2.3 on the top and a 2.3 on the bottom cancel each other out. We're left with an x over here. On the other side, we left out whatever that calculates to be. So you just use your calculator. It's okay to use decimals. Right? So we grab our calculator. We go 7.4 times 2.3, and we get 17.02. Okay? So that is our answer. That's it. Right? And you can't just look at it anymore with the decimals. We actually need to go through the steps. Okay. Let's do 2 more, maybe 3. Let's see. Okay. Let's do this one. You guys are awake. Or half awake. So here we got some proper fractions. And all the way through this year, I said, hey, we never do operations in this format. We said just usually makes it harder. What did we always do when we have fractions like this? Turn into improper format. Right, so before we begin, let's turn into improper fractions. So what is the step to turn this into improper fraction? Yes, Riley?
You got times it, then plus it.
Yeah, so you multiply, then plus. The bottom number stays the same. So what do we have for the numerator here? Right? So you got 4 times 2 gives us 8. Add the 3 gives us 11. Right? Then we have this x.
4 over 3.
No, 11 over 4.
I'm looking at the next one.
All right. Now, I'm still not done here. This x is right here. But I'm going to tell you to make life a little bit easier. If you see x written like that, just make it part of the numerator. It means the same thing. Right? It'll make your calculation a little bit easier. Right? And now we have this equal sign. And we do the other side. We multiply, then add. And Riley, what is it?
4 over 3.
Yeah. 4 over 3. Okay?
Pretty straightforward.
Yeah, good. Okay. So now we divide our equation.
Lovely.
Right? And we look on the side of the x. But this time we've got 2 numbers there. So we need to get rid of the 11 and the 4. Right? So we can treat it one at a time. Which number do you want to get rid of first?
4.
The 4. Okay. So the question is, what is the 4 doing to the x? Is it adding, subtracting, multiplying, and dividing? Dividing. What's the opposite? Multiplying. So we need to multiply by 4. Right? And whatever we do one side, we do to the other. These are
Oh, I remember this technique.
right? A 4 on the top cancels a 4 on the bottom. That's why we did it. We end up with 11x on this side. What do we end up on the other side? Sartaj? What do we have on this side? Do you know? Like, if you have a fraction, it may help to write it like that.
12 over 3.
Not 12 over 3. The over 3 is fine. 16. We multiply the tops together. We multiply the bottoms together. 16 over 3. Okay? Now, on the side with the x, we still have this 11 sitting there. What's that 11 doing to the x? Adding, subtracting, multiplying, or dividing? Multiplying. So the opposite is to divide, to get rid of it. So you multiply by 1 over 11. That's our dividing operation. And whatever we do to one side, we must do to the other side. Right? And this process is called isolating. Because all we're left with is x. It's all isolated by itself. So 11 on the top cancels 11 on the bottom. And we're left with just the x. How about on the other side? What are we left with? All right. Ethan? Yeah, 16 over 33. 16 times 1 is 16. 3 times 11, 33. Okay? So at this point, we are going very slow. We're writing a lot of extra things, and we're doing more steps than we actually need to be doing.
Can we not do one more?
As we get better, we will show faster routes, and you will have to show less work. Right? But right now, we're going very deliberately each step, so you know what's the reasoning behind each step. Now, for instance, on this question, I'm going to write this out again. At the stage where we said 11 over 4x is equal to 4 over 3, we could have used a different approach. Instead of thinking of this as 11 and a 4 as two different things, you could have thought of this as a fraction multiplying x. And you can get rid of 11 and 4 in one step. Right? We could have, if we thought of it, or if I told you about it, is we could have just multiplied. That's a messy line there. Hold on. We could have just multiplied by 4 over 11. Right? It's a 4 on the top. We'll cancel the 4 on the bottom. And the 11s will cancel each other out. We could have done this in one step. Remember, whatever you do one side, you got to do it to the other side as well. Multiply by 4 over 11. So on the left-hand side, we're still left with the x. On the right-hand side, we multiply the tops together to get the numerator. 4 times 4 is 16. Multiply the bottoms together. 3 times 11 to get the denominator. Same answer, a lot less work. As we get better at it, even more shortcuts. If you were in my grade 10 class, I wouldn't even be showing this step right here. Right? All you'd be seeing is this times this equals this. You guys are not there yet. You will be by the end of this chapter. We're just learning it. Yes, Ethan?
Why don't, I was just looking at it, why don't you just times 11 by 10 and 4 times 4? On the main question.
Sorry?
So like, see how you have just the main question altogether?
Right here?
No, like the one on the right.
Okay, this one here?
Why don't you just do 11 times 3 and then 4 times 4? Instead of having to do all that other stuff.
11. Okay, hold on. Let's do this. I'm going to write it out here. So we have this here. And what are you saying?
So do 11 times 3.
All right. 11 here.
And then 4 times 4.
And 4 times 4. Okay.
No, like 4 times 4 like that. Like what it equals.
Like,
'Cause 11 times 3 is 33.
yeah.
And then 4 times 4 is 16.
Yeah.
So then you have the answer right there. You don't need to do that extra stuff.
Yeah. Eventually you get to that stage. Because right now I want to show you where that came from. It came from this and this canceling out. And it came from this and this canceling out. Right? We did that here. We did that there. We'll get there. Right? Right? Yeah. And once you see it, like you're already seeing that, yeah, that's awesome, right? Okay. Let's do. Let's do one more. Let's do one more. Okay, let's do this one. We'll call it
And then
a day.
one.
Yeah, then I'll hand back the tests and your marks. All right? So, on this one, easier. What number are we trying to get rid of? The 4.5. What is it doing to the x? Adding, subtracting, multiplying, and dividing? No, it's not subtracting. It's multiplying. You look between the number and the symbol. There's nothing here, that means it's multiplying. You don't get confused by this minus sign out here. It's multiplying. So the opposite is dividing. So we need to divide by 4.5. 4.5 and 1. Now, if it's a negative number, you divide by a negative number to cancel out that negative sign. So you divide by negative 4.5. Okay? And whatever we do to one side, we do to the other side. So these cancel out. We're left with an x. On the other side, we have a 1.35 over negative 4.5. So if you multiply the tops together, you get 1.35. Multiply the bottoms together, you get negative 4.5. But we don't leave fractions like that. Right? If the question has decimals in it, give me the answer as a decimal. Right? If the question is just whole numbers, then give me the answer as a fraction. But if it has decimals in it, calculate the decimal out. So to calculate this, we just go top number divided by bottom number. Right? So we got 1.35 divided by 4.5. Oh. 1.35 divided by 4.5. We got 0.3. This answer isn't right. I did a shortcut because I didn't want to type all the keys into my calculator. What should the answer be? Yeah, negative. I didn't put this negative in because I knew if I just divide it, I can make the final answer negative. Right? That just means me being a little lazy with my writing. Negative 0.3. And that is our answer. Right? So I'm going to stop.